Let's get started. So today, we're going to use Wheel of Fortune, this game show, as a motivating example to talk about for loops and functions. Partially why this lecture is important is because we don't have Lab 8 this week. This is kind of going to be our chance to practice using for loops and functions before you see it on the homework next week. So 4 main parts. We're going to recap for loops, talk about pseudocode for Wheel of Fortune / go over the rules, create our own Wheel of Fortune functions, and then a video at the end. All right, so recap. In a for loop, looks very similar to a while loop. What are the 3 things we have to put in the parentheses?
You gotta get your initialization.
Yep, we have to initialize the variable. Someone else for the second one? Condition, so we have to check for what condition should the loop keep running. Someone else for the third? What's the final thing? Yeah. Yeah, we need to update the variable at the end. So these are all things we talked about with while loops. In while loops, we did them at different parts of the code. In for loops, we put them all in one line. So the syntax, again, looks very similar to the while loop. The differences are, instead of the word while, we use the keyword for. And then, as you all said, initialization, condition, and update, all on the same line. This is one of the very rare cases in C++ where you'll see semicolons in the middle of the line and not just at the end. And the reason why there's semicolons is each of these are kind of like separate statements. So just like in an English paragraph where we put periods, here we put the semicolon in the line. Any questions on the syntax? Okay. So we saw if we wanted to print Morehouse 3 times using a while loop, we had like this counter variable set up. So we had our initialization statement here, we had our condition check here, and then we had our update variable at the end of the loop. In a for loop, all 3 of those would go on the same line. So the initialization in counter equals 1, that starts the for loop, then a semicolon. Then we have our condition, so counter is less than or equal to 3, so that the loop runs 3 times. And then counter is equal to counter plus 1, that's our update. Make sense? Okay. So the for loop execution, how many times does the initialization statement run in this for loop? Just 1 time. Why does it not run every time the loop executes?
Because of the update? They're after you update it, it won't go back to 1.
Yeah, exactly. So the update will run every loop, but if we updated counter to 2, and then we came back and we set it back to 1, then the update wouldn't do anything. So the initialization is just going to run once, but then steps 2, 3, and 4 are going to keep repeating. So we'll check the condition. If it's true, we'll run the code. And then we only do the update at the end of the loop. So just like with while loops, how I encourage you to usually put the update as the very last line in your loop, with for loops, it will automatically do that for you. Okay, so we did these examples on Monday, so we'll race through them. Print the even numbers from 0 to 20. First box is initialization. What would we initialize even number to in this case? To 0. What's our condition? So that's going to be our update. That's going to go last. But before that, we have to do the condition.
Even number is less than or equal to 20.
Yeah, even number is less than or equal to 20. And then even number plus 2. Dang, I thought I'd updated this slide. Oh, actually, I guess I made these slides before Monday's updates. Okay, even number equals even number plus 2. Cool, microwave countdown. So countdown, usually with countdowns, we start at a higher value, we count down, and so our check is going to be a little bit different as well. In this case, if we wanted to have the timer start at 15, what would our initialization statement be? Yeah, and note like we have to include int, because this is the first time we're defining this variable. So it would be int time is equal to 15, and then what would our condition be?
Less than or equal to 0.
So if it's less than or equal to 0, that would print all the negative numbers. Like the loop would only run if time was negative. So
Greater than or equal to 0.
Yeah, greater than or equal to 0. I think, yeah, so with countdown, we usually use the greater than symbol because we want it to be true while it's greater than some number. And then once it reaches a number and becomes less than that, then we want to stop. Okay, and then what do we do for the update? Okay. And how can we use the new like operation assignment that we learned about?
Time minus equals.
Yeah. So if we wanted to, we could write this as so one way to do it is time equals time minus 1. The other way, if you want to write it a little bit shorter, you can do time minus equals 1. And they're both the same thing. Minus equals is the same thing as saying time equals time minus 1. Yep. Any questions there? Okay, final example, print letters in the word. All right. I think with loops, especially on Monday when I was looking at people's code, people were putting like the word, they were using word in the for loop. In this example, word doesn't change every time in the loop. The thing that changes is the position in the word that changes, or the index variable. And so in your for loop, all three statements should be related to the variable that is changing. So we initialize the variable that's changing, we use that variable in the condition, and then we update that variable. So in this case, because word isn't the one changing, word should not appear at all in our for loop header. What should appear is we could create an index variable. So if all three things are going to be related to index, first off, what can we initialize index to? Yeah, so int index is equal to 0. Then what can we put as our condition?
So index is less than 4.
Yeah, so in this case, we'll assume word is always 4 letters long. And because we start counting at 0, you can either say index is less than 4, or you can say index is less than or equal to 3. That way 0, 1, 2, 3 will give us 4 letters. And then what is the final thing?
Index equals index plus 1.
Yeah. Okay. One thing we can add to this code. So right now the code only worked if word was 4 letters long. Ooh, that's not. If we wanted to make it work for any length word, we could create a variable called int length. And we could have that be equal to the length of the word. And to use this, we use a special class function. So this is a new topic that we haven't seen before, unless you did one of the bonus problems. And you can use word.length. So the way we call this function is a little bit different than the way we call other functions. Normally we would like call the function length and then put word in the parentheses. Because word is a special string object, the way we call functions with special string objects are a little bit different. We put the name of the string variable, we put dot, and then the name of the function we want to call. Right? So if people haven't seen this, just take a note of this. Word.length. In this case, what would word.length be equal to?
6.
So what is word? Word is equal to the word bird. So it's going to be 4. Like I know we start, when we talk about index, we start counting from 0. So it's like 0, 1, 2, 3. But the length function will just give the total number of characters. So in this case, the length would be equal to 4. If we had something like boulder, right, then the length would be equal to 1, 2, 3, 4, 5, 6, 7. And so the nice thing now is instead of always saying like, before we were saying index is less than 4, because we always assumed it was a 4-letter word. Now, what can we say index is less than?
Word.length.
Yeah, word.length, or because we've already stored the variable, like the value in length, we could say like index is less than length. And so now, if we put this back to like a 4-letter word, like care, what would this read as? Index is less than what? Index is less than 4, which is exactly what we want, because then index will be 0, 1, 2, 3. Right? And then if this was something like towel, then this would say index is less than 5. So 0, 1, 2, 3, 4. And that would still give us all the letters in towel.
What are those called again? Like the extensions?
Like this dot length.
Yes.
This is a string function.
Okay.
Yeah. So the way we call string functions is slightly different than the way we call normal functions. You do the dot and then the name of the function and the parentheses.
Okay.
All right, we're going to be using this dot length when we do the Wheel of Fortune puzzles, because for Wheel of Fortune puzzles, we don't know how long the puzzle is going to be. So we're going to set up like this int length equals word.length to get the length of the puzzle. Yep. All right. So if we were to run through this, int length is equal to word.length. So as we said, index is equal to 0. Index is less than the length of the word. We increase index by 1. And then what can we see out here to print each letter on a new line? Word of index. If we just print word, it would print out the same word each time. If we do word of index, the first time we'll have word of 0, which is T, then word of 1, which is O, word of 2 is W, word of 3 is E, word of 4 is L. So index is going from 0 to 4. Any questions on this example? Because we're going to be using this very closely in the Wheel of Fortune stuff later in lecture. Okay. Okay, so we're going to write out some of the pseudocode for Wheel of Fortune. I realize not everyone might have watched Wheel of Fortune, so we will watch a small part here. As you're watching this episode, or not, we're not going to watch the whole episode, we're just going to watch 2 minutes of this. 2 things I want you to try to keep in mind. First, what is our while loop condition? For what condition do we keep playing the game? And, or don't answer yet, we'll like let people see what it looks like. The second thing to think about is what happens in a given round. So think about like what the player or the user does each time in a round, and then we'll come together and try to crowdsource the pseudocode. Okay? So the wheel is spun, lands on a value.
650.
P. Guess a letter.
2 P's.
M.
1 M. Josh, you have almost $2,000 and a grin on your face. What does that mean?
Keep spinning.
All right.
So notice he's doing the same thing each time. That's an indication of a loop.
L.
Right.
1 L, pick up that wild card. And you're up to $2,450. Will he keep spinning? In play. 700.
C.
Sure, 1 C.
Any guesses on what the phrase is?
I like to solve the puzzle.
All right, go ahead.
Please don't stop the music.
Yeah, that's it.
Cool.
Yeah.
Okay, so let's come into the pseudocode here. So the reason why we know it's a loop, I think one thing I noticed in the exams where one thing that was slightly tripping people up is, do we use an if statement, do we use a loop? The reason why you'll know when to use a loop is if we're doing the same thing over and over again. So in this case, he spun the wheel, he guessed a letter, the letter appeared on the board, then he did it all again. And he kept doing that, which is a good indication for the loop. So let's start with, in what case does he keep spinning? Like, how do we know to keep playing this game?
Why they haven't guessed an answer?
Yeah. So we'll say, let's say we had some variables that were like string puzzle and answer. So how can we use that in our while loop? Yeah, cool. So while puzzle doesn't equal the answer, then we know there's still more work that has to be done in this given round, right? So while puzzle doesn't equal answer, there's a few different things you can do. You can either try to guess a letter, you can buy a vowel, which we didn't see here, or you can just try to solve the puzzle. For today's class, we're just going to focus on the part where you just guess a consonant. So we'll just focus on guessing a consonant, kind of like what he did in this round. So what are the steps that he did at the start of each loop? Yeah, so he spun the wheel. So we can let's pretend we had a function called spin wheel. That's just what we can put in our pseudocode here. Spin the wheel. If someone saw this, they would know what's happening. Spin the wheel. Then what's the next thing that he does? Yeah, so guess letter. Cool. So he spins wheel, he guesses a letter. To guess a letter, that's where we would do the C out and C in, right? We'd say guess a letter, get a letter from the user. But for now in pseudocode, we'll just put it generally, so guess a letter. What happens after he guesses a letter?
They figure out if it's on the board or not.
Yeah, so this is key. One, we have to check if it's on the board, but also the way the game worked was if he landed on, so if he landed on
1L, pick up that wild card.
if he lands on like 650,
M.
he gets $650 for every letter that appears. So if there were 2 M's, he would get $650 times 2. So in addition to just checking if it's on the board, we also want to get like the number of occurrences on the board. So we can call it like get num occurrences. So we'd have a function that would take a letter and go through every letter in the answer and see how many times it appears. Okay? So get num occurrences. And there's 2 things that can happen, right? So we'll call it like num occurrences. If num occurrences is equal to 0, it didn't happen in this round because he always got it right, then he loses his turn and it goes to the next user. Lose turn, go to next user. Else, if it's on the board, what 2 things do we want to do? Yeah, so we could have a function that's called like update money total, right? And then there's one more thing we have to do, and this one might not be as obvious.
Put the letters back on board.
Yeah, so we'll call it like update puzzle board, right? We need to, if we never updated the puzzle, then the user would have to try to remember what did they guessed and where did it appear on the board. But here, after he guesses the letter,
1L.
we see that there's an M, and then this is the part where it updates the board, right? Like this lights up as blue, Vanna goes and updates the puzzle board, right? And now we finished everything, so what happens?
Keep spinning. All right.
Does puzzle equal answer at this point? Puzzle does not equal answer, so we do another round. And then we come back to our pseudocode and we do the same thing. We spin the wheel, which is what he does here. After we spin the wheel, what did we say happens next? So guess a letter. He guesses L.
1L, pick up that one.
So after L, what happens? Num occurrences. That's where Pat said 1L. So there's someone there who's in Pat's ear that's telling him like, all right, 1L. Does 1 equal 0? No, so we're still on his turn. So we update the money total. So that's where they show like this 1950, it had gotten updated. And then we also have to update the puzzle board, right? So it went from 1950 to 2450. That was updating his total. And then they didn't show it here, but the board got updated, right? Kind of cool how we can take like a real world example, like a real world game show, and literally put it into actual code. Yep. And I think, again, this is the hardest part of computer science, is this design portion, because it's something that we don't have that much practice with in other school subjects. And it's just something that for the rest of the semester, we're really going to be practicing. So taking hard concepts or hard games and putting it into pseudocode, and then using that to write functions to write the actual code. So in today's class, we're going to write out 3 of these functions. We're going to write out spin wheel. We're going to write out get num occurrences. And we're going to write the update puzzle. We could also do update money total if we have time. We'll see. All right. Any questions on the pseudocode? Okay. Does it make sense I want to instill like the steps we took to do it. Does it make sense like how we worked through what was the common thing that happened each time, and then how we just wrote it in pseudocode instead of getting into the weeds? Yeah? Okay. Okay, so let's write some of these functions. As a recap on functions, we start with the return type, then the function name, and then the parameters when we're creating a function. So in this isVotingAge example, we return true or false. So what is our return type here? Bool. And then our parameters, we're using this age variable. So what do we put in our parameters? Int age. And again, notice the use of data types. So here we said the data type of the return type. Here we said the data type of the parameter. Because we're creating a contract, and whoever uses our contract or calls our function needs to know exactly what to give us, and they need to know what they're getting back. Yep. Okay. So to create the spin wheel function, we saw in the pseudocode, Josh spun the wheel, and he got back some value. I know there's like other tiles on the wheel, like bankrupt and lose a turn. We'll just assume that they're all numbers. what would our return type be for this function?
Just spin the wheel.
Yeah. So in spin wheel, we're going to get some money value.
Double.
Yeah, so it could be a double. In this case, in Wheel of Fortune, they don't have like $200.5. They're all like whole numbers. So what can we do as the return type? Int. So we'll make the return type int. And then are there any parameters that we need for this function? Yeah, we don't really need anything for this because it's just spinning the wheel and giving back some random value. So there's nothing that we could use for when someone calls our function. So if we were to write this out, we're going to use the rand function. So the rand function, which you'll have used in, maybe I haven't done it in a lab yet, but in a homework problem, I'll put it up in a future homework problem. The rand function gives us any random number, and we mod it by 10. If we mod it by 10, this gives us the remainder. And if you divide a number by 10, the remainder can only be 0 through 9. And so if we add 1 to it, that's how we get a random number between 1 and 10. We store that in this int variable randnum. And then just to make the values a little bit bigger, I just multiply by 100. So that way we return the value 100, 200, 300, up to 1,000. All right, a lot of code here. Any questions on how this code works? This is like a very base function for spin wheel. If we wanted to, we could always come back and update it to make it a little bit more sophisticated. But this will at least give us some random number between 100 and 1,000, and will serve for our pseudocode for now. Okay. Now I'm going to have you all write some functions. So the one that you all are going to write first, the get num occurrences. So this function is going to take a couple parameters. It's going to take the letter that was guessed, and it's also going to take the string answer. And we want to see how many times letter appears in the answer. Okay? So I'll have you all do it in groups. When you think of, raise your hand once you write your like function header. I just want to make sure your function header is right before you start writing the code inside the function. To do that first, we'll do it in groups of 2. One of you can move over. Think about for this column when you're creating your function header, what the return value is going to be, what goes in your parameter list. Do you have any questions? Raise your hand. Mark, let's talk out here for now. So you're saying your function's going to return a char here? So that might be one of the parameters. Or what do we return? Yeah, the number of occurrences. So, and then in the parentheses, you would accept a char. Yeah, so. So again, think about the return type for this problem. You guys get here? Any questions here?
I don't know what the function is gonna be, but just write get num occurrences and then say parentheses write Charlotte string.
What is the like you can name the type? Should it be like
No, we can do that outside.
should be a string?
Like it's a code. We don't have to define like char letter again, because that's we can just use letter directly now. That's but your function header
How
looks
many
good.
times it appears?
primary list. So we're taking letter, but we also need one other thing.
Index. Parse is 0, right? Index.
Yeah, so one thing really quick here, we're saying, right now you're saying that the return type is string over non-occurrences, but what are we trying to return?
And then we just go with index.
Yeah, we're trying to return like the number of times it appears, and you kind of on line 6 find it like in enough times, and that's what we're returning. So our return type would be
So if I put num times here and returning num times.
Yeah.
Then you got me with the return values.
yeah, and so that's what like at line 5, the first thing in our function header is what the return data is. So that should match what you're returning. Okay, so I think people getting the function header, a quick tip on how to write the code inside. So let's just step through an example, right? Like let's say the answer was, let's say it was like a 4-letter word. Let's say it was like boss. Okay? And let's say we were passing in the letter S as our character. So how many times does S appear in this word? 2. And how did we do it? We checked, does S equal B? No. Does S equal O? No. Does S equal S? Yes. And if we had a counter that was counting like the number of times, we would increase that to 1. Then we keep going. Does S equal S? Yes. So we'd increase that counter again to 2 times. So we need some sort of for loop in here. And the code that we had just learned earlier was if we want to see like the length. So let's say like answer was equal to this. One thing that you'll need to use is like int length is equal to answer dot length. Right? And then in here, we need a for loop to go through every letter in our answer. So think about how you can use like an index variable here. I won't fill out the rest. It'll be on you to fill out the rest. But what do we need index to be equal to? What does it need to be less than? What do we update? And then in here, how can we get every letter in answer? And check if it's equal to a letter. So in here, you would also have like an if statement. If letter is equal to what? All right, so I'll let people keep working on it. So instead of 3, though, think about how we can use length so that it'll work for instance.
Wait, less than equal to length.
Again. I guess you don't need the else, right?
Yeah, we don't need enough.
So we just return on the outside of the for loop.
And then the last piece of the condition, does it matter, doesn't wait. Or like equal to that. That's after the for loop.
Yeah, I'm assuming the for loop is looking for the update.
Right track, just the initialization. So the last 2 are correct, but what do we want the index to start at? So that we can get every return. Are you guys in here?
We usually goes after the word.
With like, where, yeah, sorry. Yeah. Okay, yeah.
We just need the condition right here.
Okay. index is equal to 0, index is less than length, that looks good. And then we need the update. So index is starting at 0, and what do we want to do to index?
Oh, index, yeah, okay.
Yeah, we just need to increase it by 1 each time to get each letter. Alright, how are you guys doing here? Letter equals answer index. Okay, just the square brackets around index. So, sorry, like an answer index. Be like answer sub index. Yep. So that will give us each letter an answer. Num times equals num times plus 1. Return num times. Cool. Good. Okay. I think people are on the right track. Let's bring it together here. All right, we'll do this in the EdStem. Okay, so first off, let's get the function header. So what is this going to return? An int, because we're just trying to see how many times the letter appears. So we're calling it get num occurrences. And we're taking in 2 parameters. What are our parameters?
Char letter.
And
String answer.
awesome. Cool. And then in here we said so int length is going to be equal to answer.length. And then we need a variable to keep track of how many times it occurs. So I saw some people call it like num times. That's a good name. We'll use that. But you can name that whatever you want. So that's just personal preference. And then in our for loop, so the thing that's changing is the index variable. So what do we want index to start at? We want it to start at 0. We want it to be, what's our condition? Less than length. I saw some people do less than or equal to length. We don't need it to be less than or equal to, because like if our length was 4 letters long, the index only goes up to 3. So we'd want it to be like, if the length was 4, then it would be 0, 1, 2, 3. So it'll just be less than length. And then index, how do we want to increase index?
Equal to index plus 1.
Yep, equal to index plus 1, or you can also use the plus equals operator. They both work. Okay, and then in this loop, we want to check how many times the letter is in the answer. So we can check if letter is equal to what? Yeah, answer bracket index, because we want to see answer bracket index will give us each letter in answer. And so every time our target letter is equal to one of the letters in answer, what do we want to do to num times?
Num times or plus equal.
Yep. So you can either do plus equals or you can do num times plus 1, as you said. So this is like our counter variable. Every time there's a match, we increase it by 1. Sweet. That's kind of all we need in the for loop. And then what do we need at the end of this function?
Num times.
Cool. And so now, in our main function, we would have like, we'd have our while loop to play Wheel of Fortune round. Right, so in our main function, that's where we would have all of our pseudocode. We would have like this while loop, we would have spin wheel. So in our main function, we would like call spin wheel, which we wrote earlier, but I don't have in this file. Then we said guess a letter. So it'd be like C out to get a letter, C in to get that letter, right? Maybe I'll actually say it. So C out, guess a letter, C in into letter, and so we would need to create a char variable called letter. And then we'd also have our answer. So let's say answer was, it could even be what we just saw, like don't stop the music. Yep. Okay. And then here we would call our function get num occurrences. And when we call a function, what do we pass in here? So if we want to call it, what values can we pass in here? And this should be string answer. This is what our function looks like. So what's the first thing we type here?
Their guess, like letter.
Yeah, so letter. And letter is the first thing we type here, so it's going to match to the first thing here. Why did we not have to say like char letter here when we called the function? Yeah, it's already defined in the function. It just has to be the same type here. And then here we would pass in our answer variable, and that would match to this one here. Note that these two variable names don't need to be the same. I could have called this just ANS for short, and ANS, and the code will know because this is the second input, it will match to this second input here. Yep. So if we were to run this code, get num clearances. Oh, did I spell it wrong? Oh, missed an R. Okay. Semicolon at the end. All right, so guess a letter. Someone give me a letter to guess.
G.
Okay, so let's do G first. What should we expect the return value to be? 0. I realized I didn't actually like see out this. Normally we would store it, but just so we can see the result, we'll just see out it. All right, so G gives us a big random number. So get num occurrences. Why is it giving us a big random number here? We're returning an int num times.
You need to make occurrence times equal to 0.
Yeah, we need to initialize it to something to start, right? Otherwise it'll just take on some random value. So now if we try it again, and actually now that I think about it, when I looked at people's code, I wasn't checking for the initialization, so double check that. Guess a letter G, we return 0. Let's say we guess O. How many times would we expect this one to come? 2 times. Sweet. And so this is kind of cool, right? We have this function that works for anything, and it's given us the right outputs. Yep. And now the nice thing with this function is we don't need to copy and paste this code a bunch of times. We know that it works. Now we can plug it into our bigger Wheel of Fortune project. Yep. All right. Yeah. I'll also put a screenshot of this code up in the slides. Okay. So I'll create like an optional lab for people to do the next function, which is to actually update the puzzle. But let's just briefly talk about what would need to change. So if we wanted to create a function called update puzzle, the idea is we want to return the updated puzzle back to the user. So what would our return value be for this function? If we want to return back the puzzle variable. Yeah, so string, we'd call it like update puzzle. And now we need to take 3 things. We still need to take in what the letter is. So like char letter. We would still need to know what the answer is. But we also need to accept one more parameter here. Does anyone know what that other parameter would be? So we'll kind of calculate that part slightly again. We have, yeah, so like we kind of need the actual puzzle because that's what we're trying to update. So we need to know what the state of the current puzzle is. And in here, the code would actually look very similar to what we had, except now we don't need this num times counter because we're not counting the number of times. Instead, what we're going to do is if letter is equal to, so if our puzzle looked something like this, like BO, like blank, blank, if this was our puzzle, and our answer was equal to boss, and the user guessed S, right? We would check, does S equal B? No. Does S equal O? No. Does S equal S? Yes. And we would want to change this letter in the puzzle from like an underscore blank. We would want to change it to an S. Okay? So in our if condition here, we would take the puzzle index. So before, like, when we were checking like 0, 1, 2, 3, here as well, the same index is matched. So 0, 1, 2, 3. We're saying like the letter matches answer of 2. So like in this example, puzzle of 2 would now be equal to the letter. We went through this super fast. We'll put it up as an optional lab if you want to play around with it. And then at the end, we would return the puzzle. So yeah, we went through that super fast. I'll maybe cover it again in more detail on Friday. All right, final surprise, Wheel of Fortune video. So maybe some people know, but there was that day where I put up the virtual lecture on one of the Wednesdays. I guess part of the reason for that was I flew out to LA for a day to film for Wheel of Fortune. So we'll play like 5 minutes of it here. What's it? Turn up the volume? If I.
How'd you even on the show?
Yeah, it was kind of random. I don't know if I can get volume here. Oh yes.
Get ready for this first toss-up. There you go. $1,000 what we'll give away. Person is the category. Van is in place, and here we go.
That's crazy. That's crazy.
Ashwin.
Satisfied customer.
That's it.
All right, pay attention here. A little shout out.
Now you're a professor, but you're visiting. So what's the whole story?
Yeah, so just teaching for this semester, teaching computer science at Morehouse College. I love my students and working with the other faculty.
And originally from the Bay Area. And you do something called orienteering, which
Yeah.
I've never heard of.
It's where you go into a forest with just a map and a compass. You try not to get lost, and you find different checkpoints as quickly as possible.
And what do you call it?
Orienteer.
I call it being hopelessly lost. It's a different. Maybe it's a different game.
Did you have to
This is a word.
What's up?
Did you have to rehearse that?
We had a rehearsal that morning, but it was kind of just he'd ask you questions and you answer it. Yeah.
That's more than a word.
What was up?
This was yesterday?
It aired yesterday. Yeah. I filmed it beginning of September. Yeah. All right.
Here we go. And Zachary.
Lake Michigan.
Sure. Good job.
All right, so this is the part that we actually coded, the main part of the game, which is spinning the wheel, guessing letters.
And Ashwin, you'll start. And there you go.
T.
Well, I'm happy to say there's a T. That's worth $2,500. $650.
S.
One S.
I'd like to buy a vowel.
Yeah.
E.
Oh, give them some E's, man. Here they come. A 1, a 2, a 3. And there's more. 4, 5, 6, 7 E's. $550.
H.
Yeah, 2 H's. We'll add another $1,100 to your total. $4,000.
You only get to keep the money in a round though if you solve the puzzle. So there's still,
$850.
yeah.
C.
A good time for this. There are 7 C's. 8 for each one. Obviously, that's the same one.
Is it cheesecake?
Mhm.
That settles. We will add an extra $1,000 to your total, and that means you're already at $10,000.
I'd like to buy a vowel.
Okay.
A.
Yep. 4 A's. There you go.
I'd like to buy another vowel. O.
2 O's. Why don't you try them out? 900.
K.
There might be a K or 2, or maybe even 3. $13,150.
Buy a vowel.
Uh-huh.
U.
Yeah, last of the vowels. Maybe that'll do it for you.
I'd like to solve.
Go ahead.
Cupcake, cheesecake, chocolate, cake.
Yeah.
Alright, I'll just put up one final.
Dramatically pause at that one moment just to scare all of us half to death. Anyway, good round for you. $12,900. Got both.
So how do the person with the most get to keep the money?
So everyone will get to keep their winnings, but if you win, then you get to go to the bonus round, and you have a chance to like win a car or more money, something like that. Yeah.
Hey,
There you go. 4 A's after this. So you still have $1,700. What do you want to do now?
I can buy another vowel?
Yeah.
E.
Oh, give her some E's. $650.
L.
Sorry, no L. Ashley, your turn.
So if you get it wrong, then it goes to the next person.
There are 3 of them. $800.
N.
3 N's. Yeah, and bunches here. $4,200.
I'd like to buy a vowel. An I.
Sure, 2 I's.
People got it? Alright, we'll skip to the very end.
Solve the puzzle.
Go ahead.
A feast fit
Oh, you
for
went to
a
the
king
final
and
round.
Yeah, so I ended up winning.
Yeah, you got it. Come on with me, Ashley.
I would have buried the video if I didn't do very well.
R-S-T-L-N-E. We start with those letters.
Nah, this one is hard.
A lot of help to start with, but very nice. All right. 3 more consonants. 1 more vowel.
M. C.
Yes.
D.
And now a vowel.
O.
So, let's see what we get out of that. Ooh, I only heard 1 ding. But you're a good player. You can do this. Okay? Shh. Person, 10 seconds. Talk it out. Good luck.
Mechanical expert. Principal expert. Whimsical expert.
Making money here. Let's see what we didn't get. Well, don't tell them. Well, it was the Infinity.
They had like an infinity car there, but it was okay. Still a good day's work. Cool. All right. All right. Final thing: if you haven't finished Lab 7, make sure you finish it by tonight. No Lab 8 today. Enjoy homecoming festivities, and then make sure you do the Wordle presentation by end of this week. Yep. Cool. Cool. Care?
You got me a photo.
Yeah, I'll get you.